Hello and how are you? Welcome to this tutorial in which we are going to go to the third segment, which is very important in our working out of learning. This tutorial we are dedicating it greatly to practicing the art of differentiating, which basically we are still handling calculus for your information. And I am your tutor, Deb Joseph Adeli. Before we begin, let's bow down in reverence, close our eyes for a word of prayer. Father, Lord in heaven, we ask that you are able to be amidst us, teach us in the stillness of your voice. We are ready to learn. Send Holy Spirit to be able to explain every detail you are going to learn and the skill that we have to put into practice. Enable us that even after this tutorial, we be committed to be able to go look for even more questions, if not ask for more from other friends and other people who may find more, so that this particular skill and concept may be able to sink in our minds. Be with us, prepare us for eternity. In Jesus' name I pray, amen. Let's go to our specific objectives. Now I'm going to do a wrap-up summary of currently where we are with respect to the objectives, because somehow there are some particular terminologies probably may be surprised why are these things in this particular way. So I'm going to take quite some time in explaining the specific objectives, and I'm sorry that I was not able to do that in the introductory point, or basically the tutorials that came after, but I'm going to do it right away so that you may know where we are, where we are from, and where we are going. By the end of this topic, you should be able to find average rates of change, and instantaneous rate of change. Now let me explain what do we mean here. Average rates, an average rate of change is, for example, if I'm having a question, for example, they're asking you find the velocity of a car or the acceleration, for example, or basically you are being asked to find the gradient of this particular equation or a line. It's basically an average of all the data that is in that particular equation. For example, if we pick the one for velocity of a car, if you find the velocity of a vehicle when it was moving from Mombasa to Nairobi, you'll basically pick out the distance divided by the time and get the velocity directly. But here comes a question: does it mean that that car was moving from Mombasa to Nairobi at a specific speed or a specific velocity? For example, let me pick out this. For example, a bus is moving from Mombasa to Nairobi, a distance of 500 kilometers, and for example, it is moving at a speed of, let's say, 100 kilometers per hour. Now, does it mean that this particular car, because if you get that, you know that velocity is basically the distance divided by time taken, and the distance here is 500 kilometers divided by the time taken. Oh, sorry, I'm confusing myself. I've given you distance, I've given you speed. So let me say it took 5 hours so that we get it back to 100 kilometers per hour. So we have our distance as 500 kilometers divided by 5 hours, giving us 100 kilometers per hour. Now, does it mean that that car was moving at 100 kilometers per hour from Mombasa when it departed all the way to Nairobi? Certainly not. What we just got was what we call average rate of change. But instantaneous rate of change now goes to the details, very details. For example, the car moved from Mombasa when it reached, which is the market is this? I've forgotten the specific markets. Let me say when it reached at Mlolongo, it caught up with a traffic jam that took it about, let me say, 30 minutes to reach town, Nairobi town. So in that total time, you find that there was a time whereby the speed was reduced by because of traffic jam. Because in traffic jam, obviously he'll not move at 100 kilometers per hour. You'll find that he'll move, for example, at 20 kilometers per hour. Or for example, when he was at Tsavo National Park, when he was crossing Tsavo National Park, the road was very clear. There were no animals, there were no other vehicles. So you find that he blasted his vehicle at a very high speed at, for example, 120 kilometers per hour. So you find that the velocity will change with respect to the conditions. So we may decide to go narrow down and say, let's, for example, get his velocity at a specific time. That's what we term as instantaneous rate of change. It's the velocity at a specific point. So that's basically what we call instantaneous rate of change and average rate of change. I believe you now understand what they are. So average rate is basically general velocity or time or gradient general. But instantaneous rate now goes at a specific point. The velocity at a specific point. The gradient at a specific point. Find the I believe that one you are able to do because we explained also how to able to get the gradient at a curve, and that one you have to get instantaneous rate of change. Average rates, this one was covered in your previous learning about equations of a straight line, and you know how to do that also in physics, whereby you are told to calculate for velocity and all the other things. You can be able to calculate for that. So finding the gradient of a curve at a point using tangent. This case was also covered previously, whereby we were explaining about the gradient function. And something you need to know is that the tangent touches at a specific point. That's a line that touches a specific point. But we're going to also look at it in this tutorial. We're going to explain something more about the tangent. Find that tangent, the gradient that it has is equal to the gradient at that specific point. I'm only giving you this earlier so that we're able to understand what it is. So basically, getting the gradient of a curve at a point using tangent, I believe you know this. This is basically a formula that helps you to get the gradient of the curve at a specific point by use of the tangent. So in this case, you're not going to differentiate and all other things. We're just going to draw that curve, draw your line, get the equation of that tangent, and know that that's the equation at that specific point. Relate the delta notation to rates of change. This one is very common, whereby you know by calculating for rates of change, you know it's dy or dx, and you can relate all that to be able to calculate for rates of change. Believe you know that how to be able to do that. Find the gradient of a function of the form y is equals to x power n, in whereby n is a positive integer. Now this is what we are going to tackle this particular tutorial. Define derivative of a function, derived function of a polynomial, and differentiation. Now defining the derivative of a function, you have derived function. I believe this one you are able to do, whereby we were tackled in the previous tutorial when we were explaining about the different forms of or different notations of derivatives, and we're able to explain verbally of what we mean by the derivative of a function. It's basically the rate of change of that function. But if you have, for example, dy dx, it means the rate of change of dy with respect to dx. Determine the derivative of a polynomial. This one also you are capable of doing, though we are going to do practice on it. And fret not, that's what we are tackling this time also. But you are capable of doing that from what we explained in the first tutorial when you are tackling differentiation. Find equations of tangent, normals, and to curves. This is also another thing that we're tackling. So please note, point number D and point number G is what you're tackling in this particular tutorial. Ensure that you know this by the end of the tutorial. Sketching a curve shall come in the next tutorial when we shall tackle curve sketching. Apply differentiation in calculating distance, velocity, and acceleration. This one shall come now in the tutorial after sketching a curve. And also applying differentiation in finding maximum and minimum of a function. This one shall also come later. Now let's start our practice. Believe you have your pen and paper or a book. I prefer a book, not pen and paper. I'm used to saying pen and paper, but please have a book for reference afterwards, because there might some things that you may want to keep for future reference. A book is more reliable than a paper. And don't also rely on your mind too much, because we human beings tend to forget. So if you don't have one, please pause the tutorial, rush and get it. If you have that, we are good to go. Find the gradient function of the following equations. 1. Y is equals to x squared plus 3x minus 3x. 2. S is equals to t cubed minus 2t plus 4. 3. A is equals to a third r cubed. May I pause the video if you don't mind to be able to tackle those particular equations and find the gradient function. Now, if you probably are wondering what gradient function is, the gradient function is basically derivative, that particular function that shall give you the gradient, whereby if you plug in the coordinate point, it shall give you the gradient. So that equation, that unknown that requires you to plug in values to be able to get the gradient, is what we term as gradient function. So you may go ahead work out those equations, and then we shall be able to solve them together. I believe you have something at hand and you have answers at hand. In the first case, y is equals to x squared minus 3x. If we differentiate that, you'll notice that you'll have the following. dy over dx is equals to 2x minus 3. I believe you know how everything comes about, because we multiply the power, the coefficient of the unknown, by the power, and then that power reduces by 1. So I believe you can notice here we have 2 minus multiplied by x, the coefficient is 1. You have 2, then the power reduces by 1, you have to x. Minus 3, here you have power is 1, multiplied by 3, you have minus 3, and x here reduces to power 0, and you know from indices, anything reduces to power 0 is basically 1. So it remains in this particular format. Next, s is equals to t cubed minus 2t plus 4 shall have the following. So if you multiply the t by 3, shall have this, and I believe everything remains the same. Now 4 dies out because you find that 4 has an x component here, which is raised to power 1. So if you multiply that coefficient, that component of x power 1, not power 1, power 0, you find that the 4 dies out. So if you have anything raised to power 0, it means 1. But because of the multiplication, 4 dies out and everything dies out, so remain with this. Then finally, if you differentiate this, I'll have that. Now notice, I was not constantly using dy over dx because I need to know which function, which particular variables are independent, which are dependent. Notice here we have labeled explaining of x and y, so I believe I can move directly to s, but I can just begin that for formality. Find that the independent variable here is x. It doesn't require any other value to be able to define itself, but y requires x to be able to define itself. So y is the dependent variable and x is the dependent variable. Similar to s, s depends on t, so t is the independent variable, s is the dependent variable. Here we have a, and r is the independent variable, so that is the main thing you need to know. Question number 2. Find the gradient of each of the functions below at x is equals to -1. Now notice, you need to find the gradient at a specific point. That means you have to find the gradient function first. After that, plug in the value or the coordinate at that specific point you want to get, then find your value. First question, y is equals to x power 7 plus 4x squared. Next, y is equals to 2 over 3 x cubed plus x power 5 divided by 5 plus 2x squared plus 3. Then finally you have that. So you may pause the video and be able to tackle that before I give you what I have. Now here there's a trick, there are some tricks I've been able to apply here in the questions, so you need to be very careful when answering them so that you don't fall into a trap. Now notice the first one is just direct as it is. You can just differentiate this and be able to get the values, of which I believe you have the following. If the gradient function shall be 7x power 6 plus 8x. If you plug in at x is equals to -1, dy over dx is equals to -1. I believe you can see what's happening. So basically the gradient at that specific point at x is equals to -1 is -1. So this one is just direct as it is. I believe you got that. Also this one's like they are direct, but the first step matters a lot. If this other one is just direct, you get the gradient function still. If you get the gradient function, plug in at x equals to -1, find that the gradient will be equal to what? -1. So that will be our gradient. But now what about this other one? Notice everything is divided by x squared. What do? If you have gone to higher levels of learning, you shall learn of a different format, of which you call quotient rule, to be able to differentiate this. But now here, because at your level you have not learned about quotient rule, we shall not apply quotient rule here. We shall basically start by simplifying that equation into this format. I believe everything is common here. Now notice my n has become negative. I told you that can happen. So you need to learn how to tackle them. what do? If differentiating that comes to basically whatever is common, you'll find that it will be 2x plus 6x power negative 1, which basically means we have 2x plus 6 divided by x. And if you plug in everything, at x equals to 1, our gradient shall be the following, negative 8. So I believe you know from indices that anything raised to power negative 1 basically means it's the reciprocal. So we find that our gradient is negative 8. Let's learn something new now. I believe that was quite good practice. Please go look for more questions to be able to tackle them and be able to be acquainted with the skills as we also prayed for. I pray that God guides you in that. Now, equations of a tangent and a normal. A tangent is a line that touches the curve at a specific point. So something you need to know, we have something known as a tangency point. At tangency point, that's the point whereby the gradient touches the curve. Find that the curve and the tangent are parallel. That means they have the same gradient. If you believe you know from equations of a straight line, the properties of equations is that when they are parallel, they have a similar gradients. So that's the same thing. Now what about a normal? It's a perpendicular line to the tangent. So let's have a diagrammatical representation of what I've basically said here. If you have an axis, draw a curve. The line that shall touch the curve at a specific point is what we term as a tangent, which is what we have there in red. Is what we call the tangent. Now, any line that shall be perpendicular to this line at a point on the curve shall be what we term as a normal. And notice that that normal is perpendicular to the tangent. That line is perpendicular, so that's why we call it normal. Now, the gradients, how do they matter? How do they not matter? How do we come to a conclusion that they are parallel? Notice at this point, when a point is moving, let me have my pen here with me. Let me have it in blue or what? Green. That's better. No. Yeah. So if I have a point here, notice it will be flowing downwards, and the moment it touches the tangent, notice the point is pointing to. If I just pick this point, it is pointing to that direction. From this particular point. So it means it's parallel to the tangent. I believe you can notice that. So at this particular point, it points that direction. So the tangent is parallel. That means the gradient, if you get the gradient at that point, it will be equal to the gradient of the tangent. What about the normal? I believe you know the relationship between the gradient of a perpendicular lines. It is m1, the product of the two gradients should be equal to -1. So let's dive into an example, of which it's an example, yes, but you are going to try working out and fumble what you suppose may happen. From just the knowledge that I've given you, you should be able to tackle it. Though I shall guide you, and it will be a responsibility to get more questions to be able to tackle similar questions. Now, something you need to note before we continue is a guidance of how do we get the gradients. Now, to find the equation of a tangent, first start by getting the gradient function. Number 2, find the gradient of the function at a given point. That means you need to find the gradient of the tangent. Number 3, find the coordinates at that given point, if not given. Most of the time you'll be told, find, for example, the equation of the tangent of this equation at a specific point, and that point will be basically of the independent variable. For example, x is equals to a particular value, but you will not have the y component. And you will have to get it. So you have to get the y component, and that will sum up to the coordinates at a given at that specific point that you have been asked for. So the reason why I'm also insisting that, let me just try to sketch my axis here. If I have axis like that, and I have a point here, for example, at 2, notice point x can lie anywhere along this line, but notice the gradient will not be equal at each of these points. The gradients will be different. So you have to get a specific point of x coordinate so that you may have that specific point in which you are looking for at that particular point whereby you have the tangent. So you have to, it's very important to get the y component. Finally, you should be able to finalize by getting the equation of the tangent. This one, from your previous knowledge about equations of straight lines, you can be able to tackle that. Note below, to find the equation of the normal, the same procedure is followed with the inclusion of the gradient relationship, which is m1 and the product of m1 and m2, whereby m1, for example, you may pick it to be the equation of the normal, the gradient at the normal, m2 at the tangent. To product the two, get -1. Example: given the function y is equals to 2x minus 4x squared plus 3x cubed, find the equation of first the tangent at x is equals to 2 and the normal at the same point. So notice I've given you 2 points, which is from the independent variable. Now you need to get the y point so that you may get the specific point in which you are looking for. So if you don't mind, you may pause the video and be able to try fumbling about. That's how we learn. And then from what you shall have messed from, it shall be your stepping stone to leap for higher glory. Now I suppose you have something as your solution. Basically, to find the tangent, you said you start by getting the gradient function. The gradient function, basically, you shall find it as 2 minus 8x plus 9x squared. I believe you know how that comes about. Now, find the gradient of the function at a given point, which is x equals to negative, x equals to 2. The particular gradient shall be, if you substitute every point of x with 2, you shall find the gradient as 22. Now when x equals to 2, finding the particular coordinate of that point, you shall substitute it now to the function you had. So if you substitute for x at that point, you shall find y is equals to 12 here. So basically, my points shall be 2, 12, and xy. Why did I say xy? To find the gradient, you have to have 2 points. And basically, because you are now looking for the equation, we have the gradient m, which is 22. We have a point 2, 12. What about the second point? We don't have that point, and it will take us time to be able to get there, to draw that curve and be able to draw and get the gradient. So we basically get the second point as an unknown, and this one shall also lead us to get the equation. So that is the unknown. So we know that the gradient is usually equal to the change in y over change in x, the delta notation that we are speaking about. To substitute that, you find that the gradient 22 is equals to y minus 12 over x minus 2. And that quickly comes to the gradient, the equation of the tangent, which is y is equals to 22x minus 32. Very important. I believe you got that. If not, you may check where you messed from and correct it. What about the normal? The normal, we know that the relationship is basically m, the product of the two equations, is equals to -1. Now, I shall pick here, for example, m2 to be my normal that I'm looking for, and m1 to be the gradient of the tangent. So m2 shall be -1 divided by m1, whereby m1 is 22, which shall be -1 over 22. So basically, substituted into this formulae, you shall have the following: 1 over 22 is equals to y minus 12 over x minus 2. So if you work out for y, you shall find that this is the equation of the normal. And even you can attest that the product, if you multiply 1 over 22 and 22, you shall get -1. So those are the two equations of the normal, and I believe this one has helped you move a step ahead in calculus. So otherwise, success in your preparations. May God bless you abundantly. Meet in the next tutorial, in which you shall be able now to tackle curve sketching.